Okay. Example 7, Charlotte invested $4,000 in a bank account at a simple interest rate of 7.3% per year. Find the number of years it takes for Charlotte's money to double. So her initial amount is 4,000. That's not a sub 1, that's a sub 0. Remember, we're always talking about prepare first. We need to write out every single thing that we have at the beginning. It's going to help you. So please, please, please make sure that you're writing out this information at the beginning. A simple interest rate of 7.3 will help us figure out what our common difference is. It's just not 7.3%, it's 7.3% of 4,000. So that's 4,000 times 7.3%, which is 292. We want to find the number of years it takes for Charlotte's money to double. So double the amount is double the initial amount. And we can find out what that amount is by just doubling the initial amount. So if we wanted Charlotte's money to double, that means really we're waiting for how long does it take for the money to get to 8,000. In order to figure out how many terms, in other words, how many years, right? What is n? When a sub n equals 8,000, we know we're going to be using the formula a sub n equals a sub 1 plus n minus 1 times d. So we have d, we don't know n, but we know we could plug in 8,000 for this guy, and this guy would be our variable. We have d, we don't have a sub 1 yet. So we just need to really quickly say, oh, well then a sub 1 is equal to 4,000 plus 292, which is 4292. So now I've created a list of things that I can use in this formula, and now I have a plan of, oh, I've got everything I need to plug into this formula except for n, and so I can solve for n. Go ahead and solve for n. Plugging in 8,000, 4,292 plus n minus 1 times d, which is 292. You can plug this into your numerical solve or subtract 4,292, then divide by 292, and then add 1, and you get 13.7 equals n. Now the deal is that you only get this 292 US dollars at the end of the year. It's not like at 0.7, you're all of a sudden at 8,000. At the end of the 13th year, you're below 8,000. And then when you get to the 14th year, now you're above 8,000. And so keep that in mind when you're solving for n, is that we don't deal with 0.7s of a year. It doesn't happen in the middle of the year. With simple interest, with compounding interest, it does. And so that's what we're going to talk about. But for simple interest, it only happens at the end of the year, which means that your ends have to be discrete, right? It's either year 1, year 2, year 3, year 4. And so 13.7 won't work. Even if it was 13.2, we would still have to round up to 14. So right now what we're saying is, okay, at year 13, we're under 8,000, so we haven't doubled yet. At year 14, we have doubled. Even if this was 13.1, we wouldn't be able to round down to 13, because think about it, if you're still at 13, technically it takes you to get to that 0.1 in order for you to hit 8,000. So since we haven't gotten to 8,000 at 13, you have to say, oh, okay, well, I have to wait till next year to get above 8,000. So it will take 14 years for Charlotte's money to double. Or you can say after the 13th year. So at 13, it's not doubled yet, but after 13, it will double. But it does say how many years it takes for it to double, and so you wouldn't be able to say 13, it would have to be 14. So simple interest is something that's very, very applicable, something that you will, no matter what, deal with interest at some point in your life, whether you're investing money or whether you're taking money out. And this is one way that interest can be calculated. So you could go into a bank and say, is this simple interest or is this compounding interest? Say, what are my options for interest? And know that the benefit of simple interest is if you have a large chunk of money that you would like to put into a bank, that simple interest might be the best option for you because at the very beginning you're putting a large chunk of money in, which gives you a large common difference, which means that you would be gaining money potentially in the long run more than if you were doing compounding interest. So really interesting things to talk about, really applicable. Maybe go talk to your parents and be like, do we have interest? Is there interest on like money that we have in the bank? What does interest look like to you as an adult who like deals with this on an everyday? Do you know what our percentage is? Could we calculate like what is the best way for us to invest money? It would be a really interesting, good learning lesson for you to understand what this looks like in your day-to-day life with you and your family. Okay, good job.